Firescape Inspector Summary Video. Firescape Engineers, Inspector Meneses here. I'm here in White Plains. This is Firescape number 3 of 7. And this Firescape, like Firescape number 1, has the same issues. I'm going to go in detail on this one, so that on the other ones we'll pretty much refer back to Firescape number 1, Firescape number 3. The uniqueness about this one is that it makes this corner and it ties back in. But we got a lot of structural problems that tying in, especially in here. As it ties into the building, it's starting to let water get in there, and that water's causing ice jacking and rust jacking, and we got structural cracks down at every platform. Original hardware everywhere, and especially in this corner over here. Water's getting in there and rusting in that corner. More evident down below. We got AC units that kind of block your access to the ladder. That ladder needs to be secured. It's nothing but original hardware. So we need to reattach. And up and over the roof must be secured again. At the bottom it's all original hardware, secured. Our biggest issue, first of all let me speak about this rail. This is the only rail that we have up here. Yet this rail is missing on every floor down below. And if you make a miscalculation, you will fall into the pits and continuously fall 7 stories all the way down because it's missing its rail, and I'll show it. On the right side, the rail is not high enough. We need to extend another line up above. And we got cement issues. A lot of these ACs, and this AC is on, it's winter time now. We're in November, close to December, and we got an AC on, and that's dripping water, like that AC unit right there. It's causing problems. This whole wall looks like it was rebuilt or repointed, all because of a lot of times what comes from a sill, or a lot of times what comes from an AC unit, and I'll show that down below. Tie-ins, they're all popping, they're all jacking. So the forces of nature, rust jacking and ice jacking, let me show you what it's going to do on this floor down below. Okay, as you can see I'm missing a rail, so I have to be very careful. So we have rust jacking here. We have rust jacking there. We have all the bolts heads are gone everywhere. All the bolt heads are gone. So now, what occurs here is that this railing is acting like a C-channel. So that's a piece of 4-inch flat, and it married to that railing up above, it acts like a bridge truss. Every single railing bolt that ties it back to these flats is gone. And the corners are shot. So where they tie into the corners, the photographs will show. So every one of these supports that tie into the flat, that tie into this rail, have to work together. But every bolt, the nuts are gone. So the rails that were supposed to act like a truss are no longer here. The flat, that takes the nose of every piece of steel that goes out, it grabs that 4-inch flat that's supposed to grab that rail and act in conjunction with each other, in unison, and they're not. These things are only 8 to 12 inches deep into the wall, and they're solely relying on the fact that they have to join out there, tied to that flat tied to the railing, which acts like a truss, and that's why this Firescape is self-supporting, and it'll take that entire staircase. So we have a life safety issue on all 3 Firescapes so far, simply because right now everything is 50 to 75 years old, has popped. Every one of these has popped. So here we have a railing that the rails are all been eaten, and as we get further down you'll see, again, missing rails. Spalling on all these is an indication that water's getting down below, making every one of these supports suspect. So this has all been worked on. This whole wall has been worked on. Some of it has been replaced. And further on down, water's still getting in there because it's jacking out the steel. And there's evidence because some of these treads, so some of these staircases are pushed out, they're bowing, indicating that there's a force inside this wall pushing the steel back out. Look at this staircase as it bows right out. So that's an indication that something's going on inside. That could have happened when that wall that got totally rebuilt down there pushed that bar pushed the staircase, and that staircase went to the right. But again, this railing tied in with that flat acts as a truss on all floors. Every one of these steel members is 4 to 8 inches into the wall here, but then it has to rely on the nose there because it needs the flat and the rail to create a truss. None of these rails, none of these flats are solid. They're all suspect, and some of them have popped as we further go down. But here's another issue with rust jacking. See all that debris in that corner? It's rust jacking and pushing this. As you can see, it's tight up against the wall, but as you go along, it gets wider and wider and wider, and it pulled it out of the building. And that's all rust right there. Huge amount of rust in that clip. So, everything. Missing rails, imminent hazard. You can fall, if you fall to the right, you fall 7 stories. Every one of these treads got rust in them. Huge, huge rust. I'll show you some issues here as you go down. Not only does it have huge rust, they used to be something that they put in here. And look, whatever was in there, I don't know if it was an old epoxy or a cement, but they cemented these edges and then painted. And that's all porous. Look at that. And that's what's been feeding water to this fire escape on the treads on each side. So every tread is huge amount of rust. Huge. EPA renovator license applies. I mean, we got too much. This is a lot of paint, a lot of issues here with scraping and painting. So must be a licensed EPA renovator. You can see the pressure that's being exerted by this thing pushing it out. So this wall at one time that got totally rebuilt must have pushed out. And I got a big bow. And again, we're relying. So here's a perfect example of a corner, and the bolt is gone. That bolt, if you can hold on while I focus, you can see right through. Right there. There's nothing. No shaft, no nothing. Rust jacking. So all the corners are shot, all the heads are eaten or missing totally. So none of these rails are acting in unison. So everything is just gone. We got debris, we got ACs feeding water constantly to this fire escape. A lot of rust jacking, a lot of ice jacking, missing rails, life safety issue. This has got a huge amount of dirt and freeze and thaw happening there. And it totally blew out that corner there. Okay, and a lot of these huge structural cracks now on the wall, coming specifically from this corner. It gets worse as we keep going down. Look at that huge structural crack coming from that one up above. Huge. So aside from fixing this fire escape, we now have a wall issue that's feeding water into these apartments. Okay, so this fire escape does have a life safety issue, like fire escape number 1 and fire escape number 2. Not made to take a load. It's supposed to support 100 pounds per square foot, but the way that all the bolts are popped, it will not hold it. This fire escape is only embedded into the wall 8 to 12 inches, and it needs to rely on this flat plus this railing to act as a truss. I'll repeat that as we keep going down, because not many people know how fire escapes are built. And it's very important to note that it's not very deep. It's not very deep into this wall. It's through this veneer, which is only about 3 inches, and then the course of masonry wall inside, which is about 1 foot of masonry wall. Can't go any further. This is a perfect example of a false corner. From above, you can see, yes, you know, the one side has popped, the other side is still there. But now, if I come down here, you see what you really got. Nothing. Nothing's there. Okay? Rust jacking. Okay? Rust jacking. It's destroying this entire fire escape. And this fire escape is not structurally sound, because every single one of these bolts, excuse me for the wiggling, is relying. So now, look at that one. Gone. So that corner is not even there. You can see air through it. Bolts missing. Everything. So, in some of this, it's so bad. I mean, just look how bad the eating of it is. There's a lot of work here. A lot of work here. and these fire escape ACs are sticking out too far, causing an issue. No railing here, somebody's going to fall into the pit. And if you fall into the pit, there's nothing stopping you from continuously falling all the way to the ground. A lot of sills, just keep feeding water back down. That water back down. We got bricks falling. This is pieces of brick from above that have fallen. Okay. You can see it's missing the rail on the left side still. You have to be very careful when I go down. This is probably going to be getting to some of the worst floors. As you can see up there, see? It's not tied back in anymore. So that support is unsupported. It's 8 to 12 inches deep into the wall there. Hits a corner, relying on a railing and a flat, 1/4 inch flat by 4 inch, and then it'll do it'll support. Yes? Just doing a fire escape inspection. Okay, here's another unsupported corner right here. And again, looks good from the top as far as, but the bolts are all gone. But when you get down here, severe, it's missing, there's nothing there. So this is another unsupported corner. Look at all the rust jacking that's happening there. Very, very bad. Life safety issues on this fire escape throughout. Hall floors. First 3 fire escapes all have similar. I estimate that this fire escape is at least 25 years to 50 years worth of neglect. Not one evidence of any maintenance on the fire escape, meaning a change of bolt. I'm looking for a hex head. These are all square heads. I'm looking for a hex head of some kind that shows evidence of maintenance. Not since this fire escape was built did anybody ever change one bolt that I could see on this fire escape. Not one. Again, there's no evidence of a welding repair that I can see. But there's evidence of rust jacking, evidence of popping. This fire escape is structurally unsound, will not hold a load of 100 pounds per square foot in the as-is condition. Tons and tons of water getting into this one. You can see all the structural cracks. See how the water's getting in up there? Okay. We got walls. Water's getting in here. So this is consistently, I mean, look at that one. Water's going to get in there consistently. The water's going to get in there. Cause issue. That's a good example of a typical foot and how much room you really have to walk sideways like a penguin in order to not fall into the pit. And as you can see, if you fall 10 feet on average. So look at the bulging and the bowing of it right here. Every single one of these bolts is gone. So now we're pretty much done with the repeating. So that's the structural issue. Now we're going to deal with the ladder. Got tons of problems on this fire escape. 100% refurbishment in order to pass a load test. All the bolts are gone. This ladder, this hook, original bolt. Just tons and tons of problems. Look at the rust jacking there. It takes 25 years to grow a 1/4 inch. This is 1/2 inch. 50 years to grow this much rust. You can see I have the ability to almost pop it. But again, unsupported. The ladder has to be cut so that it drops exactly down to the right location. It's right over a door. So this is one of our concerns, that when you let this ladder drop, it'll guillotine down on somebody trying to get away. So they may want to extend this balcony. This is again a conversation with the inspector. And the inspector will allow us to possibly extend the fire escape to that area over there, so that when the ladder goes down, it does not hurt anybody, and there's still plenty of room to jump through the bushes there and get away to safety. Because right now it's a life safety issue when it drops down by anybody just trying to get away. They could drop it on a fireman or drop it on an occupant trying to flee the building. So again, structural. That's, we can't say enough. 100% refurbishment, licensed renovator, permits required. These are all, this is a perfect example. This is no longer tied. This is no longer tied. This is a piece of steel that is supposed to rely on that flat bar, that relies on this railing as a truss, that's supporting the steel into the building 8 to 12 inches deep. Otherwise, what it's supposed to have, if you weren't relying on the end there of the trussing and the flat system, you were supposed to have a support coming down. So let me just give an example. So I'm supposed to have a support coming from that tip down to here, a diagonal. You eliminate the need for a diagonal by doing this kind of system where the railing acts like a truss plus the 4-inch flat. It's all in unison. Without it, you have an unsupported. So you put enough load on this fire escape that will fall down in the end, coming down, and everybody in it will fall down, taking with it staircases and everything. So it'll have a domino effect. Fire escape has emergency issues, and it also is in need of a full repair, full paint job, full refurbishment, no evidence of any maintenance. Any questions? Fire escape engineers. Inspector summary video. This is Inspector Meneses, 800-649-3333.